Hello everybody, this is Horned Frog Engineering. This is problem 2.54 from the textbook Fundamentals of Fluid Mechanics, 7th edition. And in this problem we have an inverted manometer. On the left tank is a closed tank. We have CCl4, which is carbon tetrachloride. And then we have an oil inside the pipe, and then you have your water. It's an open tank on top. Remember this triangle over here denotes, the upside down triangle, it denotes that it's open to atmospheric air. So in terms of PATM, it's 14.7 psi, but in terms of gauge pressure, this is going to be 0. So we have given our specific gravity for the oil, which is in red over here, is 0.8, and we want to find the height, this height over here of the column of water. If the air over here at the tank is 8 psi and we have CCl4 with an oil right there and then water. So first thing that we need to take care of, usually for this textbook, in the inside cover of the textbook or any textbook that you use, you'll usually have this information given to you also in the book. For water, the specific weight of water is 62.4 pound-force per cubic feet. And for carbon tetrachloride, it's 99.5 pound-force per cubic foot. So now we want to find the height. So what we're going to do is, like we did before, is we're going to use the swimming method. So I drew a guy that's swimming over here. So this is your point 1 to point 2. You can start from here and you'll still get the same answer as far as height. But I'm going to start over here at point 1. We're going to swim through, down, and up through the pipe and down again and going up. So that is what we're going to do, is using the swimming method. But first we need to take care of some bookkeeping. We need to take care of, we need to pretty much find the specific weight for oil. And if you remember, specific gravity equals specific weight of the desired fluid that you want over the specific weight of water. And then we're going to solve for x, or gamma x, which is Sg times specific weight of water. And in our case, this is oil. So, and we're given the specific gravity of oil is 0.8 times the specific weight of water. So we're going to swim from right to left. And the way we're going to do that, we're just going to set up the equation in terms of its variables. We're not going to plug in all the numbers right now. And then we're going to solve for h to be able to find this h value of the height of this column of water. So the first thing that we're going to do is we have P1 at this point, and then, again, this is in terms of gauge pressure. So this is just going to be 0, but we're just going to put P1 just to be clear, because I just want to make this clear. Plus, you're going down this water right here and then up. But remember, as you go down and up, the pressure for these two are going to cancel. So your net pressure that you're dealing with is just from here to here. So it's h minus 2. You have your h minus 2 feet. Your net pressure that you're dealing with, again, is just this depth right here. And you're going to increase in pressure, so it's plus because you're going down. The lower that you go in the water, again, the higher the pressure that you're going to experience. And then you're going to keep experiencing pressure, but then you're going to decrease that pressure. So the net increase in pressure is just these h minus 2. And that's going to be h minus 2 times the specific weight of water. And similarly, the net decrease in pressure that you're going to experience is just 0.7 feet for oil. Because if you go up over here, on this point, you're going to go up, and then you're going to go down. So you're going to increase in pressure, and then you're going to decrease in pressure, and then you're going to increase in pressure. So this will just cancel out. So all you have is 0.7. So it's negative because as you go up this oil, you're gonna experience less pressure. So 0.7 feet times the specific weight of oil. And then over here, once you get to over here, you can, again, if you wanted to write all of this process right here, you can, but I feel like it's redundant and it'll save you more time. So you're just looking at the net decrease, because right here, as you're going down, you're going to increase in pressure, and as you go up again, up to this level, you're going to experience a decrease of pressure in the same way that you felt the increase in pressure. That's just going to cancel out. So this height right here is 3 feet minus 2.7, and again it's negative 3 feet minus 2.7. So just be careful with your signs. And then you want over here to be the specific weight of carbon tetrachloride, and that's going to equal P2, which is 8 psi, but we're just going to leave that as P2 just so we're clear and understand what's going on over here. So again, just to recap, we set up our equation. We are assuming from point 1 to point 2, as you're going down, the net increase in pressure is just H minus 2 times the specific weight of water, because this is going to cancel out and you just have a net increase right here, and then you have a net decrease of from here to here, because this is going to cancel out. So it's negative because it's a decrease in pressure, 0.7 feet times the specific weight of oil. And then you're going to go up in pressure and then go down in pressure, and this is going to cancel out. So all you have left over here, the net decrease in pressure is just from here to here, which is 3 minus 2.7. And then don't forget that negative, because you're decreasing in pressure as you go up, times the specific weight of carbon tetrachloride equals your pressure at point 2, which is 8 psi. All right, we have the formula set up. I ended up just cutting this because I just wanted to make it easier. The way I did it before is I ended up solving for H, and then plugging in all the numbers, but the unit conversion is doable, but it's going to be a nightmare. It's going to be a little bit disorganized. I feel like if we do it this way, plug in all the numbers first, and then set up the units, show our units, because the teacher's going to want you to show your units, and then we'll do the algebra afterwards. So that's what we're going to do right now. On this left side of the equal sign, and then this is the right side. The right side is going to be, we want this in terms, right now this is in pound force per inch squared. We want this to be in terms of pound force per feet squared, because when we solve for H, we want that to be in H. If you do leave it in pound force per inch squared, you're just going to have to, it's okay, it's fine to do that. H is going to be in terms of inches, and you're just going to have to convert it into feet, but we're just going to do it in all in one step. So we want both sides of these to be equal to pound force per cubic feet. So we're going to start with P1. P1 is just atmospheric pressure. Again, atmospheric pressure. PATM is 14.696 psi, but in terms of gauge pressure, which is what we want, this is 0 psi. So 0 pound force per inch squared. Again, this is 0, but usually your teacher is going to want to know want to know that you know what you're doing. So you're going to want to show your units. So we have pound force for feet squared for this term right here, plus H minus 2. This is in feet, remember. And this specific weight of water is 62.4 pound force per cubic feet. And then you have we have foot over here, foot times foot times foot, and then up here in the numerator just 1 foot, 1 foot, and then you have foot squared, because this will cancel out up here. So you have foot squared. So we have pound force, foot squared, pound force, foot squared. So we're checking this one, checked on that one. And then next thing we have is 0.7 feet. And then for oil, we did our bookkeeping earlier, is 0.8 times the specific weight of water, which is 62.4 pound force per cubic feet. And this is going to cancel with one of these feet. This is leaving this to be foot squared. So we have pound force, foot squared. Perfect. Minus 3 minus 2.7 feet times the specific weight of carbon tetrachloride, which is given in your textbook as 99.5 or somewhere close to that. I have the 7th edition, so this may have been updated, possibly, who knows. One of these foot is going to cancel with one of these, leaving us with foot squared. And then this is going to equal your P2. Your P2 is 8 psi. So 8 psi is in pound force per inch squared, so we're going to want to convert that. And the factor is 144 inch squared equals 1 foot squared. So we have foot squared. So we have foot squared over here on the right side of this equal sign, and on the left side we have pound force foot squared on the right side, pound force foot squared, pound force foot squared, pound force foot squared, pound force foot squared. And all we have to do now, once you show your units, usually your teacher will want to, as long as you're clear with your units, you can just pretty much do algebra at this point and just work with the numbers. So this is going to be 0, and then plus, if we distribute 62.4 to this term right here, it's going to be 62.4h. I'm just going to put a parenthesis to make it clear that's a variable that we want, minus 62.4 times 2 minus 124.8, and then minus 0.7 times 0.8 times 62.4, that's going to give you 34.944. And then this whole term, be careful with your negative, distribute your negative, and then distribute this 99.5. You're going to be left with 29.85 equals 8 times 144 is 1152. So this part right here, you're just showing your units because you want to be very clear with your units. Most professors, probably all of them, will want you to show your units. And then after you show your units up here, then you're just left with the numbers. Simple algebra at this point. And then what you're going to have is, if you combine all of these and then move it to the other side, you have 62.4 h, 1,341, 594. If you solve for h, you're going to be left with 21.5 feet. And that is our answer for this problem. So just to recap, we have a inverted manometer with 2 tanks, one water with open air and one closed tank on the left side. We did the swimming method to set up our equation. Our equation that we got was P1 plus H minus 2 gamma H2O minus, because you're decreasing, because as you go up, you're decreasing in pressure, 0.7 foot times the specific weight of oil. And then the net, as you go from here to here, it's going to be a net decrease in pressure. And that net decrease is 3 minus 2.7. 3 minus 2.7 feet times the specific weight of carbon tetrachloride. And that's going to equal your P2, which is 8 psi. Afterwards, then we plugged in the numbers. You could solve for H, which is, I think what I did during the school year is, for this specific problem, I solved for H, but then the unit conversion was a little bit more disorganized, I believe. So instead of doing that, I plugged in the numbers and then converted this to pound force per cubic feet, so that once we solve for H, we have it in feet. If you don't do that, it's going to be pound force per inch squared. This is going to be in terms of inches, so you can just do the extra step afterwards and convert to feet afterwards. So once you have your units, then you just plug in the numbers. Make sure you're clear with your units. After you're clear with your units, then it's just straight up, straightforward algebra at this point. And your H, the height of this column of water is going to be 21.5 feet. And that's going to be the final answer. All right, thank you for watching.